Hey, so hopefully you gave this problem a try before watching the video for the answer. If not, pause the video, try it on your own, and then come back and resume and we'll go over it together. So we want to let f be a function defined by f of x equals this piecewise function. Our first subfunction is 6 plus 3x for x's that are strictly less than 1. Our second subfunction, 9 plus 2 natural log of x for x's that are greater than or equal to 1. And we want to know, is f continuous at x equals 1 according to our formal definition of continuity. So we're going to check each of these three criteria for continuity. The first is f of a defined. So we want to evaluate f of 1 for this piecewise function. And the subfunction where that would be defined is 9 plus 2 natural log of 1, and we learned how to evaluate natural logs in an earlier unit this year. So we know the natural log of 1 is 0, 2 times 0 is 0, so this evaluates to be 9. Okay, next we're going to find the limit as x approaches 1 from the left side, and that's for the function f of x. And approaching from the left would be x's that are less than 1. So we're going to be evaluating the linear subfunction, 6 plus 3 times x, and we're substituting 1 for the x. 3 times 1 is 3, plus 6 is 9, right? So far, our evaluated function at a and our limit for the left side approaching a, those are the same. Now we need to check that the limit from the right side is also equal to 9. So we want to find the limit as x approaches 1 from the right, and that's the function f of x. And coming from the right side, that's going to be x is greater than or equal to 1, which we already evaluated, 9 plus 2 natural log of 1, that is equal to 9. And because we've shown that all three of these are true, that f of a is defined, that the left and right-sided limits are approaching the same value, and that the limit as x approaches a is equal to f of a, right? Now we know that the function f is continuous at x equals 1 by definition.